Hello and welcome to lesson 3 on the binomial distribution. And today we're going to be looking at using the cumulative distribution function tables. They're the ones you'll find in these beautiful green books, like the Edexcel one here, or often in the back of your textbook or even online. So make sure you have this handy from the start. Okay, just to warm up, a bit of work for you to do by yourself, so you need to pause it in a second. Here's the deal. There are 25 balls in a bag. Okay, I've listed you 5 scenarios here. The first thing to do is write the scenarios as inequalities. So, for example, the first one, greater than 4 blues, you write as x is greater than 4. So think about greater than 4, it means it doesn't include 4 itself. Then it says write them as a less than or equal to probability. So this means greater than 4 would mean everything from 5 upwards. So we can write this as, so we're looking at a less than or equal to, we're actually looking at things going this direction, which would be all of that. So you could write this as 1 minus the probability of x is less than or equal to 4. Because we want all the chances that are more than 4, i.e. 5, 6, 7, 8, 9, etc. Therefore, we don't want this stuff down here. So you do 1 minus that. So you're going to pause it now and write out the inequalities down here. Then you write your probabilities down on this side, and the probability must include this sign only. Right, so no more than 6. So we are allowed 6, and we want no more than that. So nothing above it, just below. So you're going to want this section down here. So x must be less than or equal to 6. And it already has that sign, so we just write this. Don't be afraid to use a number line. You are never ever too good or too old for a number line. So at least 2 blues would be, you can have 2, because at least 2, so it's 2 and upwards. So x needs to be bigger than or equal to 2. And writing it in this form, so we don't want those 2. So we do 1 minus probability that x is less than or equal to 1. Fewer than 8, so it's got to be less than 8. It's not including 8. So it's everything this side. So fewer than 8 fewer than 8 means less than 8. And with this sign would be what probability x is less than or equal to 7, because we're not including 8. And at most 5 blues. Well, it means we're allowed 5, but no more than that. So x is less than or equal to 5. Again, it would be probability x less than or equal to 5. This becomes very important, and you realize that in a second. So think about our bag of 25 balls. 5 are blue. We're told we draw 10 balls with replacement, so the probability of getting a blue doesn't change. If you take them out and not replacing them, then each time we take a ball out, the probability is going to change, and it's no longer using our binomial distribution. So we need to first write down what our distribution is. So using x again, it is binomial, because it's with the replacement, and there's a fixed number of trials. What is the fixed number of trials? Well, we're drawing 10 balls, so 10 is the fixed number. Don't be confused and write 25. We're drawing 10 balls out. And the probability is going to be 25, so 5 out of 25, which is 0.2. Right. what we can do now is use our table to work out all of these probabilities in this scenario. So we've used this table before, or similar table in S1 for the normal distribution. The trick with this table is, if you look up here, the table shows less than or equal to values. So if I want the probability that x is less than or equal to 6, well, I have 10, n is 10, so we're going to our n10 bit down here. And you can quite see the top of the page. Our probability is 0.2. So here's a probability, so find 0.2. So look at this column down there. Right, what's the chance that x is less than or equal to 6? Which read across is 0.9991. Okay, the top one, 1 minus probability x is less than or equal to 4. There's that one. So this is the chance of getting a 4, a 3, a 2, a 1, or a 0. And that is going to be 1 minus 0.9672. And what we need to do now is quickly finish this off and find out using your table these three values there. Okay, there is your answers. You can pause it and mark it. Common mistakes is not reading off the table properly. So make sure you might always use a ruler to help you find the right row and the right column. And make sure that if you're doing a 1 subtract sum, you do write down 1, subtract the number, and then your answer. Don't just jump straight to the answer. Okay, make sure we communicate our work effectively in a mathematical way so everyone can understand it. Right, this scenario. So using the same scenario where you got n is 10 and the chance is 0.2. On a probability, you pull out fewer than 10 but more than 2. So again, you're never too good for number line. So fewer than 10 means it can't include 10, so I'm looking at 9 and below this way, but more than 2. So more than 2 can't include 2. So looking at this range of numbers. Remember our table, so we can probability that, let's see, x is bigger than or equal to 3, and less than or equal to 9, essentially. And remember our table only shows the less than or equal to numbers. So something we need to do is the probability that x is less than or equal to 9 says all the way down here. This will give us all of this. But we don't want that section. So you've got to take away probability that x is less than or equal to 2. Because number 3 we do want, 3 is included, we want that, so just less than 2. And then you grab your table, 0.2 again, down to the tens, and 9 is given as 1, and 2 is given as 0.6778. Okay, and then you do a subtraction and find your sixth solution, which is 0.3222. So probability that x is less than 10 but more than 2 is 0.3222. Notice I've written down the two ones I'm looking at, their numbers, in the sum, my answer, and then my answer line based on what's in the original question. Do a couple more examples. The probability of more than 5, but at most 7 blue balls. So probability that x is bigger than 5 and at most 7. So at most 7 means you can include it. So looking at most 7 So it can include 7, but more than 5. So 5 is not included, we want more than 5. So that's just 6 and 7. Now you could do this by hand, using the actual formula, or using the table. So I'm going to need to find my biggest numbers is 7. So I'm going to look at x is less than or equal to 7. Again, that's going to be from 7 all the way down. We don't want, 6 is fine, we can have 6, we don't want 5, but anything below 5. So to take away the probability that x is less than or equal to 5. Again, I can't stress enough, don't think you're too old for number line. You can still use it and it's massively helpful. I can't stress that enough, just how useful number lines are. People get very complacent sometimes and make mistakes because they think they are awesome and flying and too good for it. And take away 5. From 2 down to 5 is 0.9936, which can leave you with 0.0064. Alright, pause it, have a go at this. What's the chance of getting exactly 3 blues? Okay, well, remembering that our number line, here we go, so 3, I'm going to do a bit of just part of a number line, don't need all of it, so exactly 3, just that. Now remembering our table gives us less than or equal to, so less than or equal to, the biggest number is 3, because it's the only number, okay, and our table will give us 3 in everything below. But we didn't want 2, 1, etc. So you take away probability x is less than or equal to 2. And from our tables, you should have found that 3 is 0.8791 and 2 is 0.6778. So we can subtract them. 6778 gives us 0.2013. So probability that x equals 3 is that. And you can check that using the formula learned in previous lessons. That's it for today. Make sure you have a good grasp of that. Don't forget, guys, go back, watch parts of it again or pause it as you go along and make good notes in your book.